Assalamu alaikum and good morning. Today I'll be presenting about a topic related to forensic science titled Vibrational Spectroscopic Approaches for Semen Analysis in Forensic Investigation, State of Art and Way Forward. Sexual assault is one of the most heinous and sensitive crimes in social as well as forensic contexts. The crime is so heinous as it tremendously affects the physical and the psychological health of the victim as well as society. The trauma is so severe that in majority of instances, it takes several months to years for the victim to recover. Therefore, law enforcement agencies around the globe prioritize the investigation as well as courtroom procedures for sexual assault, keeping in mind the severity of the crime. Aside from that, forensic science has a pivotal role in the investigation process of this type of assault as it gives rapid and accurate information regarding the case and the perpetrator from the exhibit collected at the crime scene. Among the significant exhibits typically encountered in sexual assaults, semen is considered the absolute priority, as in a considerable majority of cases sufficiently prove it to be of conclusive evidence. Hence, the analytical procedures regarding semen and its stain related to a crime typically encompass the most important section in the investigation of sexual assault cases. It is desirable to carefully extract accurate information regarding the stain or fluid and preserve the evidence for DNA or other analysis. However, the traditional techniques are out of favor as they naturally tend to alter the sample profile completely or partially. Even the existing techniques are statistically well validated as required in judicial proceeding of the results obtained from forensic analysis. Lastly, vibrational spectroscopy is one of the front runners in this field because this technique does not require sample preparation as well as perform rapid analysis with optimum sensitivity and specificity. This research made by University of Bundelkhand, Jhansi, India, has multiple importance that puts it at the pinnacle of the focus in solving sexual assault cases. The first importance is to prove that the physical or sexual contact occurred, which it can show that there is a point of interaction between the victim and the perpetrator. Secondly, this analysis can help forensic officers to identify the perpetrator and thus may give closure to the victim, aside from allowing the victim to get some justice over the circumstances. Next, sperm and semen are the most reliable marker in sexual assault cases because DNA profiling starts from the identification of a stain as seminal fluid. Once sperm and semen are present in a fluid, a great deal of DNA contained in it can lead to the identification of the suspect. Lastly, it can assist to estimate the time frame when a crime happened. Semen is a complex mixture of several biochemical cellular and non-cellular components. It is the contribution of multiple glands. The major contributor to the composition of semen is the seminal vesicle around 45% to 80%, alongside other contributors such as prostate gland 15 to 30%, pubourethral and litter glands approximately 5%. The minor contributors to the composition of semen are the epididymis and ampulla. The pH of semen ranges from 7.05 to 8.3, while the ejaculation amount generally lies between 2 milliliter to 5 milliliter in healthy males. Semen is typically composed of cellular and non-cellular chemical and biochemical components. All of the cellular and non-cellular components of semen are produced from different glands of the human reproductive system. During ejaculation, semen is typically a heterogeneous fluid due to incomplete mixing inside the human body. The analytical process of semen predominantly consists of tyrosine deposition, identification, species, race determination, and DNA profiling. All of these steps are necessary prior to DNA analysis, as in several cases, the information regarding one or more of formation analysis potentially solves the crime or inhibits the investigation from being misleading. These analytical steps also reduce the potential of irrelevant evidence and specific exclusion of probable suspect. Alternative light sources such as UV, visible, and IR have been used additionally to locate virtually invisible semen stains. Aside from that, most of the existing analytical techniques for forensic evidence have fundamental lacunae, as they lack the reliability, specificity, and sensitivity required in the court of law to reach a justified verdict. Some are comparatively more destructive in nature, as they alter the chemical profile of the sample, and the instrument is mostly designed to discard the used sample. Most of them are time-consuming and require skillful operators, aside from being expensive. On the contrary, molecule-targeted optical spectroscopic techniques are comparatively less destructive, not destructive in major instances, because it makes minimum or no sample preparation, rapid, cost-effective, sensitive, as well as robust in nature. IR and Raman spectroscopy have indicated the highest prospect because they satisfy most of the requirements for an ideal technology for the evidence analysis at the crime scene and also a larger part of the laboratory setup. In the analytical approaches, there are two types, which includes vibrational spectroscopy and statistical approach. So in vibrational spectroscopy, both techniques are robust and shows optimal specificity and sensitivity and is also collectively known as vibrational spectroscopy. Aside from that, atomic mass, geometry, and bond strength are reflected in the spectra. The symmetry of the molecule determines whether a vibration is active or forbidden in IR or Raman. However, both techniques are complementary to each other and only different based on the principle. As for the statistical approaches, it is the measurement of data obtained from the chemical species. The vibrational spectra are a multidimensional complex form of data that needs proper pre-processing before the advanced chemometric treatment. Data processing efficiently intensifies medium and weak signals as well as eliminates noise to make spectra suitable for further analysis. IR spectroscopy has emerged as one of the most explored techniques for evidence analysis in forensic science. The replacement of the traditional sampling technique with the ATR, attenuated total reflectance assembly, increased the interest of experts and analysts to employ this technique because it is rapid and accurate. Semen is a complex biochemical substance containing molecules that transform dipole moment that is active to IR radiations. The IR region, mostly mid-IR, is the most suitable region for semen analysis because the functional group of protein, lipids, and carbohydrate absorb IR at this range. Water is IR active. Hence, since semen has a high concentration of it, semen-specific spectral features can only be identified as water evaporates with time. As can be seen in the picture, the spectrum shows the identification and discrimination of the commonly encountered body fluids at the crime scene. Significant macromolecular contributions for all of the fluids by ATR-FTIR spectroscopy have been studied. Some significant peaks can be seen at 1,625 cm 91 for amide, 2,941 cm 91 for metal stretch of lipids, and 1,450 cm 91 for bending of asymmetric CH3. In contrary to IR spectroscopy, water is inactive for Raman signals. Hence, the water content in body fluids, including semen, is not a barrier to the analysis. Raman scattering is the modified version of Rayleigh scattering. The scattered radiation alters the polarizability of the electron clouds in a sample. Raman spectroscopy uses a laser instead of traditional radiation sources such as ND-YAG 1064 nanometer, which decreases the risk of fluorescent and sample damage. The 532 nanometer and 785 nanometer lasers are the most significant from a forensic point of view. Raman spectroscopy enables a non-contact as well as an in-situ analysis as a hybrid setup of microscopy with spectroscopy. As can be seen in the picture, all of the key components typically range between 1,750 cm 91 to 650 cm 91, although it consisted of distinct bands. Several strong and medium bands correspond to amino acid, typically at around 1,616 cm 91. Albumin can be seen at 1,448 cm 91 as well as choline. There are challenges deduced and future possibilities predicted for this research. For the challenges, some of the significant queries remain unanswered, which still hinder the practical applicability and legal acceptance of the sophisticated technologies. Most of the study mimic different factors to convey effects on the analysis. However, it's still not optimum as factors in real scenarios work cumulatively on the fluid state. Aside from that, environmental factors such as temperature, humidity, and natural contaminants influencing the identification of semen are still partially explored or unexplored. Semen is a fluid produced inside the human body, and its quality potentially alters due to the possible genetic abnormalities, accident, or deliberately induced factors. Only a few studies are available directly focused on the semen stain age estimation at the crime scene. As for future possibilities, in upcoming years, a careful investigation of the queries can solve the problem and enable the technique robust and universal for the analysis of semen. Raman indicates advantages over IR as water is inactive and hence can independently investigate the aging of semen stained by using this technique, including possible affecting factors. Since IR and Raman spectroscopy is complementary, a cumulative approach for the analysis, including both techniques, can identify semen-specific compounds simultaneously, and the statistical result will be validated. The instrument should be converted into a portable form to make it field deployable and user-friendly, since the main goal is to obtain maximum information from the semen sample at the crime scene. Lastly, a method validation study should be performed for a robust and flexible spectral database. In a nutshell, semen remains as the most significant evidence in sexual assault investigations. The focus of researchers in the forensic fraternity shifted towards non-destructive analytical methods because they can draw accurate information without altering the properties of the sample, such as the physical as well as the chemical nature. Aside from being rapid, cost and energy effective, and sufficiently reliable with both qualitative and quantitative information. Aside from that, it can also be manufactured as a portable device to make it field deployable and user-friendly. Identification, discrimination, species, race classification, and deposition time are the focus of researchers that promises good results. However, several limitations are still unaddressed, such as the effect of extreme weather conditions, man-made contamination, and a wide range of substrates. Thank you.